Welcome to our new venue for filming here at the library. Behind you can see some unrelated enzymes. Yeah.
Someone's going a little bit more hardcore than us, but that's okay.
Looks like biochem.
Yeah.
I'm glad I'm not in that as well as this at the same time. Okay, so we'll start off at the beginning. A very good place to start. We'll start with number 1. We saw that, or we concluded that A was the 5' is on the right, and 3' is on the left of that sequence that is given of mRNA. For B, we got, I don't know if I need to read it all the way out. Essentially, it's asking for the template DNA strand. So if you just take that mRNA that was given and go as if you were going to put their complementary, and then you just go through and put its complementary bases to it. U's will get A's, and G's will get C's, C's will get G's. U's will get A's, A's will get T's. That's how it goes. So we went through with all of that. You can see the sequences out here. For C, then it's going to be the same as the mRNA, just with all of the U's replaced with T's, and showed the polarity. With D, we drew it out like so. Didn't ask for the polymerase, but we got the coding strand and the template strand as it goes out. Actually, I'm going to say the top is the coding strand, the bottom is the template strand. So orange is coding, green is template. Goes out and it loops right here. And you can see the mRNA is being made that way. So the 5' end is coming out. It will be on this side, and the 3' is on this end. That's about it.
All right. So for number 2, it was just fill in the blanks. A is TBP binds directly to the TATA box, while the sigma factor binds directly to the -10 and -35 sequences. B, guanylyl transferase. C is group 1 introns for the first blank and group 2 introns for the second. D is CPSF. E is TF2B, and the second blank for that is TF2H. F is SNRPs and uracil-rich small nuclear RNAs.
Alright, so on to 3, we've got for A, the ones that work for proteins that are in the prokaryotic or eukaryotic that act as helicase are TF2H and RNA polymerase. For B, we got the P protein. Then for C, we got small nuclear rich. Is it the same thing? We got one. We only needed.
Yeah.
We only needed 3.
Mm-hmm.
Oh. Yeah, so there's multiple, but SNR and P is one, but so are all the U1, the U2, U4, U5, and U6, I think that was. So one of the 3 out of those ones. D is a sigma factor, and E is poly A polymerase.
So 4 is kind of hard to explain a little bit, but basically what you do is we just drew a genomic DNA. So you have the coding strand and the template strand. And if it's pre-mRNA, you're going to see the intron loops where it's sucking together, kind of. And so you can see that right there. And then your R loops are basically the stuff that's in between the intron loops. And so for B, when you're looking at the mature mRNA, you're just going to see these little lines where the introns used to be, and then you'll still see them on the template DNA. For C, I kind of drew mine just a tad wrong, but you won't see the intron loops because it's mature mRNA that we're talking about. But anytime there's something wrong with the like a defective donor site or a branch site adenine, you're not going to have the intron loop show up. It's just going to stay in the mRNA and doesn't get deleted out. And so if you're to look at an immature mRNA, you'd see 3 of the intron loops, but in this case you'll see, you know, one doesn't form and it still keeps that intron. And then the same goes for D. You'd have the second and the fourth introns that didn't develop correctly, or they had a defect in them, and so they don't end up getting spliced out, and the other 2 do. I hope that made sense.
Okay. For 5, we have A was a negative 35, RUT and NUSA. Fill those requirements. B is negative 25 enhancers, group 1 introns, group C box, or no, group C, GC box, and TF2D. And also SNRNP and silencers. C is negative 35, TF2D, RUT, NUSA, SNRNP, and D would be negative 25, negative 35, GC box, enhancer, silencer, and group 1 introns. And that will about cover it. Have a great Thanksgiving.
Happy Thanksgiving.